Next, we're gonna stick with Bokeh, but we're going to download some different data using Pandas data reader. So this is something we just installed. We can find out a little bit more about that. Actually, let's see what other functions we have available. So you can see just by looking at this, this is a data for getting package for getting financial data. So you have all these different data sources, NASDAQ and Yahoo and Google, for downloading financial data. And a lot, of course, there's a lot of people interested in stock prices, and the Pandas package was actually developed for financial data. So this is a really core part. There are some things to be aware of. So namely that there's a lot of different sources to get the data from, and so just using this data reader function, which is under Pandas data reader, it's data.datareader, and then you can specify the symbol, and then the source, and then the start and the end. So Google is one source. It will warn you that Google has been unstable since late 2017, meaning sometimes it doesn't work to download the data. I've had better success with one with the Morningstar source, but they all give you slightly different versions of, or slightly different output. Let's see if this works. And you have to specify a start and end using a Pandas datetime object. So we're going to start at 2007, June 29th. So June 29th, 2007, this was the date the original iPhone was released. And we're going to end today. So it gave us a warning, not an error. So a warning just says the Google Finance API has been unstable, but it seems to have worked. So we can look at the first few lines of that file. So it's a data frame with the index column as the date, and then the open, the high, the low, the close, and the volume. So we'll look more at that data in a little bit. So when we're doing a time series graph, we need to tell Bokeh that that's the kind of graph we want to do. So what we do is, when we create the figure in the first place, in addition to maybe specifying the width and the height, we can say x-axis data type equals date time. Then we make a line, because the line is the kind of glyph that we're interested in, and then we use the index as our x-axis. We'll use the close as our y-axis. We can specify a color and an alpha, so a transparency for that line. We'll label the date, the x-axis as date, the y-axis as price. We will have this option to add some extra color features, so we can make every other line, every other band on the y-axis can be colored, so you can clearly see. You'll see what that looks like in a minute. So we can specify the band fill color and the alpha for that, and then just the file name, and then create and show the file using show. So we're gonna do that, and so we see we have the price from 2007 till today. If you zoom out, you'll see these bands now. You can kind of see more what the bands are doing. They don't always look. They do pretty well, but on that first view, it looks kind of strange because it's not showing us a band down here. So it just helps us to get a little more definition, so we can see which part of the graph we're looking at. And we can save, we can reset, we can pan, we can do a box zoom. So pretty handy. We can also look at a different time series, which is the precipitation data. So this is the monthly precipitation data. So this is we used this in a previous lesson, but the one that you used for your homework was the daily precipitation data that went up through 2018. This goes up through 2016. So we're gonna import that CSV file, convert the date column to a date time object. We're going to get the mean for each date because there's a couple data points in that data set that have duplicate dates. We're going to add columns for month and year and reset the index and then view the data table. So this is what we get after we did all that. Now we can generate a figure with the width and the height. Again, we're going to specify a date time as the x-axis type. We're going to have a bunch of tools here, and we're going to create. So the way that we would create both circles corresponding to the individual time points and a line connecting them is to make two separate glyphs. So we have the circles here and the lines here. And then we're going to call the output file precip.html and then show that. So we get this nice plot of monthly precipitation data in La Jolla. Again, we've got ability to highlight certain points or to do a box zoom. We can scroll in and out, reset. We have this hover tool which will show us the value of the data point that we're hovering over, which is pretty useful. So we can see where these particular high precipitation events occurred. So next, we want to look at how we can provide additional information to make vectorized colors and sizes. So we can basically provide sequences of data values for glyph attributes like fill color and radius, and then there's a few other things we're going to introduce in this example. So we need NumPy for this example, so import NumPy. And then we're going to have an n of 4,000, so this would be 4,000 data points. So we create random lists of x and y. Whoops, didn't mean to do that. We're going to and then the radii will also be random. We'll specify some colors. And then we're going to do the standard static mode content delivery network. We'll have call this color.html with a certain title. And then we're adding a bunch of different tools here that we'll cover. I'm not going to do that. And then create the plot with range from 0 to 100 on both axes, and the tools that we specified up here. Then we create the radius of each circle. Will have the values in this vector radii. Same thing with the colors. And if we generate that and then look at that, we get this awesome looking amalgamation of randomly spaced and sized different circles that we can then, this is all specified just using a random number generator. So again, we have the ability to highlight certain points, to do a box zoom, to do a box select, to zoom in and out, to do a poly select. We can also undo and redo. So let's reset here. So if we want to just go back one step instead of all the way to the beginning, we can do that. Let's say you've done a bunch of different things, or you want to go back to where you were, you can redo. And then there's basic zoom in and out. You notice when you're doing something rapidly, it doesn't draw everything. It kind of, to save computational time, it waits until you're done zooming, and then it renders it. And you can see there's this crosshair thing that shows us where the cursor is, and this hover thing is getting kind of annoying, so we can turn that off. So a lot of different optional tools that we have at our disposal. The next thing is getting into some additional functionality. Is we can make multiple plots that have the same data but are rendered differently, and they can talk to each other. So when we pan in one, that will pan in the other, or if we highlight some data points in one plot, they'll be highlighted in the other. This example has some linked panning. So when changing the range of one plot causes the other to update by sharing range objects between the plots. So we're going to use this under the layouts module, this thing called grid plot, and under the plotting module, again, we're going to use figure, output file, and show. Again, we're going to prepare some data, provide a file, create a plot, and here we're going to create a second figure, but the x, we're going to provide this argument x range and y range that are set to the first figure's x range and y range. So now these two figures are linked, and so we can now create circles, or we had circles in the first figure, triangles in the second one, but these data sets are linked, or the ranges are linked, I should say. So when we zoom in on one, we'll zoom in on the other, and we can also create a third plot that only shares the x range but not the y range. And then we'll make a grid plot where we have the three plots all together in a grid. So let's see what this looks like. And we turned off the toolbar in this one. So we have, the data set we have is a sine wave in y0, a cosine wave in y1, which is the second plot, and sine plus cosine in the third plot. And in this, the second plot is linked to the first one in the x and the y range, and the third is only linked in the x range. So you can see if we move the x in one, we move the, if we move the y in one, we also move the y in two, but not in three. But if we move the x in one, we move the X in all three. So there's partial linkage in this third one and complete linkage of the axis ranges. So this is handy if we have multiple panes and we want to resize or change the axis in the first one, it will automatically be updated in the second one. And as it says, the pan is still present and active, and then we can click and drag and see how they're linked. Another linkage that is useful is linked brushing. So this is where a selection on one plot causes a selection to update on another plot. And so here we're going to see how we can share a column data source between the two plots and see how that works. So here we're going to use a new function called column data source. Again, we're going to prepare some data with some sine and cosine waves, provide a HTML file, and we're going to use this new function called column data source, which will be a data source that all of the plots will share. We specify some tools, and we create a figure with those tools, and then we plot on that. We're going to make a left one figure and then a second figure, and then we're going to put them together in a grid plot where we have left and right. So left will be x and y0, which is the sine wave, and they have a shared data source. And on the right will be this cosine wave using that same shared data source, and then we generate a grid plot. So these are no longer linked axes, but if we highlight, if we highlight some points in one, we'll see them highlighted in the other. So with sine and cosine, these are shifted phases, right? So when you highlight this part above, this positive part of this one sine wave, we get the other phase of the cosine wave. Let's do. And it works this way too. So this can be really handy if you've got, again, multiple data, and you might want to combine this with the sharing the x and the y range, so you have both features together. Where you're displaying multiple things, multiple variables, and you want to, when you highlight them in one plot, you want to see them highlighted in the other plot. This last part, I'm just gonna leave it here. I'm gonna skip over it because as of this week, I wasn't able to get it working in this version of Bokeh. Basically, what this does is it generates a plot in the notebook that then has some toolbars where you can control the features. Like you can say control the amplitude or the period of a sine wave with some toolbars, and those should be showing up here, but it wasn't working. This is less useful for a notebook, I think, because in the notebook you're kind of generating more of a static plot. It's not for other people to use, it's for yourself, and you have control over how you render things in your graphs. I see the main advantage of Bokeh as generating a way of visualizing data that you can share with other people or make it more of a resource. So that's Bokeh. I'll take any questions before we move on.
So I tried